Namaste students. Uh, we were discussing 21st January shift seconds physics solution. So in part 2, let us start from question number 15. Okay. Question number 15. The total length of a potential wire PQ is 50 centimeter in the arrangement shown in the figure. Find out balance length PO in centimeter. Okay. Here are the balancing condition meter is given. 6 ohm resistance, 4 ohm resistance. This is distance x, means length of PO. Let us say this is y. Total length from P to Q is given as 50 centimeter, and we have to find x. From meter we know that 6 divided by length x is equal to 4 divided by length y. From this we can say that y by x is equal to 4 by 6. So 2 by 3. So y by x is equal to 2 by 3. We have to find x. So further, using component notation, we can say that y plus x upon x is equal to 2 by 2 plus 3 by 3. So x plus y is equal to 50. X as it is 3 plus 3 is equal to 5 by 3. So 5 into 10. So x is equal to 30. So length of x is equal to 30 centimeter and y of 20 centimeter. Okay, next question. In YDAC experiment, central maxima shift by 20 mm. If a slab of thickness 20 micrometer and refractive index mu is placed in front of one of the slit, if distance between slits is 4 into 10 - 4 meter and screen is placed 1 meter away from slit, then the refractive index is alpha by 10, then find alpha. Okay. In the YDAC arrangement, here shift of fringes is 20 mm. Thickness of slab is 20 micrometer. Refractive index of mu, and this is given distance between slits, means small d, and this is capital D, distance from slits to screen. Okay, and we have to find alpha by 10, where alpha by 10 is equal to mu, say alpha is 1. Okay. So maybe you know that in a previous shift, means 21st January first shift, same question was asked, but in that question there was asked about thickness T, and in this question we have to find for mu. So you know that same question are repeating in next shift, consecutive shift. So if you have time between your second shift, you can solve some question from any source, from any of the sources. Okay, so let us solve this question. Due to this slab of thickness T and refractive index mu, the additional part difference will be created, and so the maximum is shifted from distance y. So additional part difference delta x can be written as T into mu minus 1, and y is written as delta x capital D by D. We know that this problem. Okay, so using these two equations, let us put value of delta x in this equation. So y will become T mu minus 1 d by d. So y d by d into d is equal to mu minus 1. So from mu is equal to y d upon dt plus 1. Okay, so value of y is 20 into 10 to minus 3. Small d is equal to 4 into 10 to minus 4. Capital D is 1 and thickness is 20 micrometer. So 20 to 10 to minus 6 plus 1. Okay, so 20 cut, 10 to minus 2 minus 1. 4 into 10 to minus 1, 0.4 plus 1. So 1.4 is equal to mu. So mu is equal to 1.4 and mu is given as alpha by 10. So alpha by 10 is equal to 1.4. So alpha is equal to 40. So this is our answer. Okay. Next question. A medium having conductivity 10 Siemens per given epsilon r by epsilon r is equal to 2. Okay. Here this is conductivity sigma. This is frequency. This is a right constant or relative permeability of medium. Okay. We have to find ratio of maximum displacement current and conduction current. So, but here are some changes in the question. Here asked about ID by IC, but we will find IC by ID. So IC max divided by ID max. These questions are memory based questions, so some changes are in this question. So we will find IC by ID and answer is given according to this question, this ratio. So we will find IC by ID instead of ID by IC in from question. Okay. So first we will solve for IC. We know that conduction current IC can be written as NEAV. Okay. We can write the VD in the form of mobility, and mobility is VD by when E is electric field, so VD will become U into E. Put the value of VD in this equation. AE VD is equal to mu into E. Further, mobility can be write as mu is equal to E tau by M. Put value of mobility in this equation. MAE mobility is equal to E tau by M into electric field. This is conduction current IC. Okay. We want to introduce sigma. So formula of sigma is equal to NT square tau by M. Let us see equation 2. Let us take ratio of these two equations because we have a value of sigma and not of tau and M and mass. So IC by sigma is equal to ratio of N A square tau E by M into N square tau by M. So M will be cut, N cut, square cut, tau cut. So IC by sigma is equal to A and IC will become AE into sigma. Further, electric field. This is the general formula of electric field. We want to find the maximum conduction current. So we have to write the general electric fields formula. So IC can be written as A sigma, and we can write electric field E as a E naught sin omega t minus X. We can use cosine function 2 instead of sine, or in omega 2 minus kx we can write omega t plus or minus kx, whatever we want. Okay, so from this IC means maximum conduction current value can be written as A sigma into E. Let us say equation 3. Further, now we have to calculate for ID displacement current. So displacement current ID can be written as epsilon d phi E by dt. We can write epsilon as a epsilon naught epsilon r. D phi E by dt can be written as E into A. So A is constant. So epsilon r A d by dt. Electric field can be written as E naught sin omega t minus x. So E naught is constant. So epsilon naught E r area into E naught. Differentiation of sin will become omega into cos omega t minus x. Okay, this is displacement current time. So from this equation we can say that this is the value of maximum displacement current. So we can write ID max is equal to epsilon naught ER A E naught omega. Let us see equation 4. So we have to take ratio of IC divided by ID. Sorry, here is IC max. So IC max by ID. For this we will insert page, change the background. Okay. So IC max is equal to A sigma E naught, and ID max is equal to epsilon epsilon r A E naught omega. A E naught omega. Okay. Let us take ratio. So IC max divided by IC max is equal to area will be cut, E naught cut. So in numerator sigma and denominator epsilon epsilon r into omega. So let us take the good value. Sigma is given as 10. Value of epsilon we know at 8.85 into 10 raised to minus 12. Epsilon r is 2 and omega is 2 pi into f. Okay. So 2 into 5. So 5 by 8.85 into 10 raised to minus 12 into 2 into 3.14 into F. Value of frequency is 100 megahertz. So 100 into 10 raised to 6. Further calculation, we have to use calculator. Just a minute. Okay, 5 divided by 8.85 divided by 2 divided by 3.14 divided by 100. This will come out to be 0.000899 into 10 raised to minus 12, 6. So 10 raised to minus 6 and this will become plus. So 3 into 3. So 899. So this is written as almost 900. So ratio will come out to be 900. And our answer is 900. So one of the good question from electromagnetic waves. Okay. Next one. In a circuit, there is a battery with internal resistance R and EMF E, which is connected to external load resistance R is shown. Find value of R so that the maximum power dissipates across R. Okay. For maximum power dissipated from R, the value of R should be equal to internal resistance of battery. Bro, we have derived this formula. So R must be equal to internal resistance. So power dissipates will be maximum. If you want any if you want the derivation of this formula, why R is smaller, then kindly comment. We will upload that derivation. Okay. 19. Two spheres of same mass, small element, radius r and charge at separation 4r are moving with the same speed u toward each other as shown in figure. Find the u minimum so that they collide. Okay. Here are two spheres of mass m and charge q. Both spheres have initial speed u, radius r, and initial separation is 4r. We have to find u minimum so that they collide. So in this condition, these two spheres are separated by distance 4. After colliding, let us draw equation. Diagram when they are colliding. When they are colliding, the distance between their centers becomes 2r. Okay. And when they are collided, then the velocity of both will be 0. So kinetic energy of final will become 0. So from this condition to this condition, we have to find u minimum. That what is the value of u so that they both are collect. So for this we have to conserve energy. So total initial energy E initial is equal to total final energy E final. In initial energy, both have kinetic as well as potential. And potential energy of two types in this question because they have mass. So gravitational potential can be considered, and they both have charge. So electrostatic potential also will be considerable. So initial energy they have kinetic energy plus potential energy in form of gravitational plus initial potential energy of electrical energy is equal to in final energy the kinetic energy will be zero but they have a final potential energy of gravitational potential energy as well as electrical potential energy. So U final gravitation plus U final electric. So K initial will be both have mass same and velocity is same. So we can say that half mu square plus half mu square plus for gravitational energy distance between both are 4r and mass is m. So we can write minus g m upon 4r. Okay. Plus electrostatic potential both have charge q, so we can write kq square upon 4r is equal to final gravitational energy when they are colliding. Distance between their two centers is 2r, so we can write final gravitational energy is equal to gm square upon r plus r 2r plus final electrical energy potential energy. So distance is also 2r, so we can write kq square upon 2r. Okay, so we have to calculate for u. So from this condition we can write this is mu square minus gm square by 4r plus kq square by 4r equal to minus gm square by 2r plus kq square by 2r. Okay. Let us transfer these two terms in right side. So mu square is equal to this minus will become positive. So gm square by 4r minus gm square by 2r plus kq square by 2r plus will become minus, so kq square by 4r. Further simplifying, after taking LCM as 4r, so gm square minus of 2 gm square plus taking LCM as 4r, so this will become 2 kq square minus kq square. Here is mu square. So mu square will become, so for that we have to insert page and changing paper background. Okay, so mu square is equal to gm square minus 2 gm square, so minus gm square by 4r minus gm square by 4r plus 2 kq square minus kq square, so this will become kq square plus kq square by 4r. Okay, so we can write kq square by 4r minus gm square by 4r and u square. So u square is equal to kq square by 4r into m minus Gm square upon 4Rm. Mm will be cut. So kq square by 4mr minus gm upon 4r. So you can be written as kq square upon 4mr minus gm by 4. Let's match the options. kq square by in denominator 2mr condition is given. So okay, gm square is given. Let us multiply by m by n. So kq square by 4mr minus gm square upon 4mr. So take LCM as a 4mr. So kq square minus gm square. This is our u minimum. So that they will be called kq square minus gm square 4mr for option A. Okay, next question. In an LC circuit at t equal to 0, capacitor is fully charged and 0 current in circuit. At t equal to t naught, 25% energy of capacitor goes into inductor. Then value of t naught is okay. At t equal to 0, maximum charge is stored in capacitor. I is 0. This is inductor. Okay. In LC circuit, t equal to 0 and t equal to t naught, 25% energy of capacitor goes into inductor and value of t naught. So in this data, that is given that at t equal to 0, capacitor is fully charged and current is 0, means there are no store of energy in inductor. So this is initial condition. So U max will be q square by 2c. Q square by 2c. Maximum charge is stored on capacitor. Okay. And at t is equal to 0, U of inductor, potential energy of inductance is 0 and potential energy of capacitor is q square by 2c, where q is equal to maximum charge because potential energy is maximum. Okay. And at time t is equal to 0, sorry, t is equal to t naught, given that 25% energy of capacitor goes into inductor, means 25% are stored in inductor and 75% energy stored in capacitor. So U capacitor will become 3 by 4 of U max and U inductor will become 1 by 4 of U max. So let us write UC is equal to 3 by 4 of U max and U max is equal to Q max square by 2c. So UC is equal to 3 by 8 Q max square by c and UM is equal to U max is equal to Q max square by 2c into 4. So UL is equal to Q max square by 8c. Let us equation 2. So energy is capacitor goes into inductor, then value of t naught. We have to find t naught. Okay. So for t naught, from t naught, we have a formula that at any time charge of capacitor, we have to first find charge of capacitor after t naught time is passing. Initially charge of capacitor will be maximum. After some time like t naught, the charge will be changed. So we have to find what will be the charge at t is equal to 0. Okay. So for that we have formula that at time t is equal to 0, at t is equal to t naught, energy of capacitor is equal to 3 by 4 of U max. So at that time, energy of capacitor can be written as Q square by 2C is equal to 3 by 4 of U max square by 2C. So 2C to C cut, Q square is equal to 3 into Q max square. From this, Q can be written as root 3 into Q max. And this is Q at a time t is to T naught. And in LC circuit, LC oscillation, we know that Q can be written as Q maximum into cos omega t is equal to root 3 into Q max. Okay. Sorry, here Q square is equal to 3 by 4 and this will become 2. So 2. Why? Because at t equal 0, cos theta will become maximum and charge on capacitor will be maximum. So Q max cut, cos omega t is equal to root 3 by 2. So omega t is equal to root 3 by 2 is equal to 30 degree, and 30 degree can be written as pi by 6. So this is the time is t naught because charge is at time t is equal to t naught. So omega can be written as 2 pi by t is equal to pi by 6 into t naught. Pi cut. So t naught will become okay. In question we have to write in form of LC. So let us put LC. We know the formula of omega. Omega can be written as 1 upon under root LC. So omega can be written as 1 upon under root LC into t naught is equal to pi by 6. So from subject make the subject t naught. This will become under root LC into pi by 6. So time will be under root LC pi by 6. Under root LC pi by 6. At this time, energy of capacitor will become 25% energy in inductor and 75% in capacitor. Okay. Next one, find omega such that block does not slip on the surface of cylinder. We have to find omega of the cylinder so that the smaller object cannot slide in the surface. Okay. We can we'll draw this diagram like mg is acting downward, friction will be act upward. This is rotating like this. So m omega square r will act right side and normal will act left side. This is not sliding, so all forces are balancing. So upward force is equal to downward force. So we can write that friction force is equal to mg, and friction force can be written as mu into n, and from equation n can be written as m omega square r. So substitute equation 1 and 2. So we can write mg is equal to mu m omega square r, m cut, then g is equal to mu r. So omega can written as g by mu r. So omega is under root g by mu r. Okay. So g by mu r in question option 1. Next one, for a diatomic gas undergoing an isomeric process, work done is 100 joules. Then calculate heat supply during the process. What will be the heat supply during this process? This is work done is given. So work done is 100 joules. Calculate heat supply. We have to find heat supply. Okay. And process is isomeric, means P remains constant. In isomeric process, we know that Q is written as NCP delta T. Okay. Gas is diatomic. So for diatomic gas, value of degree of freedom is 5, and Cp can be written as f by 2 plus r into delta t. Okay, sorry, f by 2 plus 1 into r delta t. Okay, so we can arrange this f by 2 plus 1 into nr delta t is q. In isomeric process, work done also can be written as nr delta t. So we can write q as f by 2 plus 1 into nr delta t can be written as work done. So put the value of f and work done. So degree of freedom is 5. 5 by 2 plus 1 into 100. So 7 by 2 into 100. 50 into 7 into 3 50 joule. So supplied heat will become 350 joule. Okay, next question. For the given network, the net resistance across AB is equal to X, then find the value of X. Here said that resistance between A and B is X. Then what is the value of X? Okay. Here you can see that 2R and X are in series and equivalent of this with R is parallel. So let us say that equivalent of 2R plus X is R1 and R1 and R will be in parallel. So first of all, R1 can be written as 2R plus X, and R1 and R is parallel, and equivalent of R1 and R can be written as X. So from parallel combination we can say that R1 into R upon R1 plus R is given as X, and we have to solve for X. So put the value of R1 in this question in equation. So R1 is considered as 2R plus X into R upon R1 is 2R plus X plus R is equal to X. Okay. Okay, R1 is equal to 2R plus X into R. R1 is equal to 2R plus X plus R into X. Okay, we have to calculate for X. So further multiplying R into bracket. So 2R square plus XR upon 2R plus R, 3R plus X is equal to X. By multiplying cross multiplying, 2R square plus XR is equal to 3RX plus X square. Okay, 2R square is equal to 3RX minus XR. So 2XR plus X square. So we can write this as X square plus 2XR plus 2R square is equal to 0. Sorry, 2R will become negative after going right side. So X square plus 2XR minus 2R square is equal to 0. So you can see that here is the quadratic equation in form of X. So we have to solve for X. So from this quadratic equation, A is 1, B is equal to 2R, and C is equal to minus 2R square. Okay. From quadratic equation, we know that X is equal to minus B plus or minus B square minus 4AC upon 2A. Let us say A. Okay. Minus B is equal to minus 2R plus or minus B square. B square is equal to 2R square minus 4. A is equal to 1 and C is equal to minus 2R square upon 2A. 2 into A is equal to 1. And the simplifying, minus 2R plus or minus 4R square minus minus plus 4 into 2 is equal to 8R square upon 2. So we can write minus 2r plus or minus 8 plus 4, 12r square upon 2. So after giving a separate denominator, minus r plus or minus 12r square, 2 will become 4 after going into root. So 4 into 3. So minus r plus or minus under root 3r square. This is x. Okay. So root of 3 will become 1.73. So 1.73r from the minus r. Simplify minus plus or minus root 3. Value of root 3 is 1.73, and if we consider plus, then answer will be positive, and if we consider minus n, then answer will be negative. So we have to consider this as a positive. So we can write x equal to minus r plus root 3r square. So we can simplify this ahead, that root 3r square minus r. So root 3r minus r. So after common of r, root 3 minus 1 is equal to x. So r into root 3 minus 1, and this is the answer. Okay. So basic question can be made lengthy by applying maths. Okay, you can see that quadratic equation is forming, and after solving we get this answer. So generally using some maths for lengthiness. Next question: VRMS of O2 gas at 47 degrees Celsius is equal to VRMS of H2 at what temperature in Celsius? Okay, here is the data for O2 and for H2. Let us say O2 and H2. Gas 1, gas 2. Here VRMS 1 of oxygen and VRMS 2 of hydrogen is equal when temperature of T1 means O2 gas is 47 degrees Celsius. Convert into Kelvin. So 273 plus 47, 0, 12, 320 Kelvin. And for hydrogen T2 we have to find. Okay. So temperature of oxygen is given, VRMS of both the gases are same, and we have to calculate temperature of hydrogen. For that, VRMS of both gases will become same. So from this equation, we have to write RMS speeds formula. So VRMS can be written as 3RT by m0. Okay, so 3R is constant for both temperature and atomic mass changing. So VRMS proportional to under root T upon m0. But VRMS for both gases are same. So we can say that T1 upon m01 plus is equal to T2 upon m02 is same. So here T1 one terminology is considered as oxygen and 2 is what hydrogen. So T1 is 320 and m01 molecular mass of O2. Here m01 is 32, and for hydrogen this is 2. So m01 is 32, and for T2 m02 is equal to 2. So root will cancel. This is 10. So 10 is equal to T2 by 2. So T2 will become 20 Kelvin. We have to convert this in Celsius because answer is given in Celsius. So from Kelvin to Celsius, 20 Kelvin. From Kelvin to Celsius, we have to minus 273. So 20 minus 273 will become minus 253 degrees Celsius. Okay, minus 253 degree Celsius. So Argon's temperature will be this. Next question: energy of an electron in Bohr's model is minus 0.04 electron E0 electron volt, where E0 is ground state energy. If L is angular momentum of electron and h is Planck constant, then 2 pi L upon h is equal to, okay, total value of this we have to find. Okay, first of all, let us find that in which state the energy of hydrogen will become this. So we have a formula of energy that minus 13.6 upon n square z upon n square. So for hydrogen z is equal to 1, so E can be written as minus 13.6 n square. Let us say question 1. Energy of hydrogen is given as E is equal to minus 0.04 E0, and this is also can be written as in form of E0. So minus E0 minus, let us question 2 and 3. Dividing equation 2 by 3, we will get that 1 is equal to 0.04 E0 divided by E0 n square. So E0 will be cancelled out. So 1 is equal to 0.04 into n square. So 1 upon 0.04 is equal to n square. So this can be written as 100 upon 4 is equal to n square. So n will become 10 by 2. So n is equal to 5. So electron will be in the 5th orbit. So you can say that 2 pi L upon h. What is the value of 2 pi L upon h? So from angular momentum, L is equal to nh upon 2 pi. So 2 pi L by h is equal to n, and n is equal to 5. So we can write as 5. So value of n or 2 pi L upon h is given as 5. So answer of this will be 5. Okay. So this was the last question. So you can say that this paper was quite average. In previous year 2025, the JEE session 1 was quite harder, and you can say that NEET 2025 paper is also harder than this paper. Okay. So in next video we will discuss about next paper. Okay. Thank you.